So you split the components and then you multiply them.
I'm not sure. Because if you're plugging in at any given point, you're going to plug in the same number for x and the same number for
So it's
y.
by like.
If that makes any sense, I don't really know how to explain that.
It's like the way you can
Well, it's by the whatever.
While this line exists, I'm trying to find
Cosine of 60. So it should be or cosine of 45. What's the? Yeah, 45.
Oh.
So it's 1 over the vector separate from x and y. So you have to split up the vector. So the same thing you were doing yesterday. We have 1 comma 5 square root 3 and 5 comma 0.
That's why I'm saying get the slope
But what I'm not sure about is when I come here and I make x minus a, or when I see x minus a, I'm realizing, well, that's technically 0. Because if I'm plugging in anywhere, x is x and a is the x-intercept that I care about here. Because once I find the intercept, I also find the x that I'm trying to calculate this for. And so I end up canceling this out. And you end up just getting this simple form, which is quite nice, but I'm not sure if I'm allowed to do that because I take the derivative of this using theta as a constant, but over here it's still a variable. And I'm only considering x as the variable, and theta is not a variable here, but it works. And that's my question. That was kind of a roundabout way to say it. I was trying to explain it well also.
That it works?
Yeah.
No way that it looks like
Away from the order.
like some of the proofs
Or
limit definitions of like
Why did it break? It didn't break.
What did you right
What did you try to go on the other?
You have to split them up into the x and the y like we were doing yesterday. Yeah.
By the sine and cosine of that.
I think you can get the x by the cosine of the y.
Pi over 4? Yeah. So pi over 4 is 45 degrees.
Yeah.
I just have it on auto.
that's something I did on my own that I was like, oh, I have to ask about this.
How will you define slope? How do you define slope?
Slope is the
here I have 2 because it's 2x and 2y. So you go through 2
Andrew,
x
can you make sure that my assumption is not completely wrong?
and you're multiplying it by cosine theta from
Andrew, stop recording me. I need help.
Oh, as long as you understand what we're like, things you're adding,
Andrew, okay. So, Andrew, are you going to talk behind the camera? Okay. So, Andrew, I thought of it as, you said that, slope is a function of direction, right? So what I thought is your x and y, x squared plus y squared equation is giving you the speed you can go in the x direction or the y direction given 0 elevation. So, like if you're hiking, right, and you have a mountain that's like, let's say, a paraboloid, if there was no z, then you could move, you could move at 2x in the x direction, and you can move at 2y in the y direction. But because there's z, your movement in the z direction, or your movement in like this zxy direction, right, along the paraboloid, is a fraction of what you would move in the x direction and what you would be able to move in the y direction if there was no like mountain, if you were just like on a flat plane, okay? And so if it's a fraction of the x and a fraction of the y, and it's given by direction, I was thinking that it must be cosine and sine, right? Because cosine, we can write all unit vectors as cosine and sine. So if we just like use cosine to represent the x and sine to represent the y, then we could say cosine times the speed of the x, and then sine times the speed of the y, and then we add those two together, that would give us the speed of the z. I don't know. That's what I've been doing so far. Is that right? Is it? Okay, thank you.
I'm so glad we caught that on video because that's so lucid and so correct and so wonderful.
Lucid.
Sebastian, repeat what you just
Is lucid a good thing?
Yeah, this is actually really cool.
I like lucid dreaming.
Nick, what is that?
Oh. Wait.
Do you know what
It was
that's?
on-
That's the paraboloid.
Kelly Poon impulsively 3D printed a hyperbolic paraboloid.
Yes,
Are we
I saw
allowed
her
to
cutting
Yeah,
it
yeah.
impulsively.
Yeah.
The issue is that
Okay.
it's just for like a proof, right? Who did that?
Kelly Poon. Yeah.
Wait, but that's not our paraboloid. That's not what our paraboloid.
Yeah, it is.
It's the one in the second problem.
Oh.
Yeah.
X squared
See,
minus.
look.
Except like trim.
No, and it has it in the thing.
Oh,
Yeah.
That's a paraboloid. Where are the parabolas? How did you draw them?
Andrew, I'm not getting zero.
Okay, well,
from this.
let's call this.
Also, remember
It's annoying.
the inner direction, y has like a ratio between x. What is that ratio?
Oh yeah. This is.
Oh, show the pyramid. The donut, the ring, the bubble ring. Show the bubble
You
ring.
don't. It's not.
Wait.
It's gonna be
X tan theta, right?
right.
Why does that not work? Oh, negative one.
So now what do you have?
Basically, you have like a thing, and then you can use.
Andrew, do you usually put all of your equations midline, or do you sometimes bring them over to the x?
Big line. Yeah.
Midline?
Oh, you figured it out.
Technically,
He just.
whatever.
Oh, so you just like pick a random point on your surface. And then it spits out.
Did anybody get 19.3?
Maybe.
Hold on. And what's the? Do you have it calculating something?
I got 13.6.
Oh no!
I might be wrong. I don't know why it's missing. That's zero.
What?
Wait, Nick, I might have the same thing as you. One sec.
I got 19.3.
Okay.
You got 10 plus 10 root 2.
What?
Did you get 10
I didn't do it that way.
Oh, can I see how you did it?
At that point.
If I put this
Yeah,
in
because
this
we're not trying to
latex,
find it relative to.
F of X plus A.
If we put a picture of this in the latex on it,
So, what?
the visual make a 3D representation.
So we already know that.
Well, because you part of it is the
I'll be
root.
doing a picture of it in the latex.
You're right.
I don't know how to put a picture on
Dude,
it.
we can't get anything except for 14.1.
Basically,
I'm sure you're doing it on
what
purpose.
this is.
I think we're
No,
closer
but that's the
to
same function as this.
Exactly.
How do you 14.1
No, but then-
do anything?
Then this would
Then
become
you
0,
just-
and then I
then-
get this,
then you
and
have
I
that.
get this.
Yeah,
That
then you're
same
just stuck
thing,
where you
but-
were before.
We did
What?
the original coordinate, the x coordinate times cosine of theta, which
X
is 45, so
plus
2
F
root
X
2 over
plus
2.
A.
And then square that, add it to the same thing but with a y and sine, and then take the square root of that whole thing. And then that equals like.
No, I fully moved. It's 19.3.
Yes, go!
I fully.
Oh,
Dude,
let's go on in.
I'm a breaker.
Yeah, screw you, Zod.
How do you screw your
diffy Q equation?
Yeah, so how do you do the Pythagorean?
I don't know how Arc10 worked, but it did.
Yeah.
It's gonna be somewhere.
Yeah,
A is gonna be equal to something.
That was like a side tangent to say like why something. I don't
Comma.
really care why.
Okay, so we're right originally.
One of the inputs
For the
in
second
that
time.
Yeah.
Yeah.
I
the
might have really good
inputs in
second
that
original.
is gonna be the
Yeah,
same
yeah, yeah.
as that. And one of the other inputs is gonna be different from